Today's video is going to be about divergence and the integral test. First, we got to go over the few requirements to be able to use the integral test to be able to see if a series converges or diverges. So the first requirement is that the series or the integral you use has to be continuous for the x value and the x range you give it. This will make sense in a little bit. So it has to be continuous, so it can't be to where we have let's say a 3 over x minus 1. And let's just say your interval starts at x has to be greater than or equal to 1. So this gives you x, 1 minus 1, which gives you 3 over 0. And this is infinity, so it is not continuous in this interval. Where it is continuous is if we were to make this interval this. For x is greater than or equal to 2. You wouldn't have that gap in this interval because this would just be 3 over 1. And then 3 over 2, and so on and so forth. So your function that you use has to be continuous for the interval you choose. The second requirement is that your function has to be positive throughout the interval. Let's just say the same interval. And let's just say, let's see. Let's just say is use the same example. If you were to use 2 minus 3, this becomes 3 over negative 1, which this becomes negative 3. This cannot happen. So what you would have to do is you would have to choose something that's significantly greater than 3 that makes it always positive and also doesn't make it diverge into infinity. So for this one, we could say x has to be greater than or equal to, let's just say 4. Because if we were to make it to 3, then it would be not continuous. So let's just say 3, 4 minus 3. This is 3 over 1. Now this is continuous and positive, so we can use this interval. And the last one is the function you use has to be non-increasing for the interval you choose. So for example, you could choose something like, let's just say 1 over, let's say x. Now this would be non-increasing because this right here, if you were to put 1 over 1, let's just say you start at 1, then that'd be 1. 1 over 2, that would be 1 over 2, which is equal to 0.5. Now you see how it's non-increasing? Non-increasing is the same thing as saying decreasing. It's just the way you actually say the word. But non-increasing is the same thing as saying decreasing. And sometimes for some functions, it is not clear and obvious that if it's increasing or decreasing. Therefore, you have to take the first derivative, like you learned back in Calculus 1, to see if it's actually non-increasing or non-decreasing. Now let's just start off with some fairly understandable practice problems. So we have the series starting at 1, going on to infinity, of k e to the negative 7x squared. This might seem a bit difficult to solve, but we can make it a little bit simpler. So first of all, we have to check the 3 requirements to see if we can use the integral test for this. But first, we have to make a function that mimics this function right here, this series right here, which we can call this a sub k. a sub k, we can say that it mimics a function that's f of x. Now we can also say that x can be a function, or it can be a variable that mimics this x. That way we can use x intervals, and then that way we can use integrals later on. So let's see. Is x, well, we would change this k right here into x. And then to a negative exponent, this right here, that would make it into, that would make it go into the denominator. So that means it'd be x over 7 to the 7k squared. Now, the range here is for x is greater than or equal to 1, because k starts at 1. And we're saying that k will mimic x, so that's why our interval is x is greater than or equal to 1. That's our interval. So first of all, is it continuous? So let's just plug in the first number. 1 over e to the 7, 1 squared. Is that equal to a number? Yes, it is. It is just equal to, well, we don't have to simplify this, but it is just equal to 1 over e to the 7. Now, the first requirement is checked off. It is continuous. Continuous. Check. Now, is it positive for that interval? Now, we can plug in the same number, this right here, and it is positive. So, it is positive as well. Check. Now, here's where it gets tricky, and here's where it goes back to where I said you have to take the first derivative to see if it's non-increasing or non-decreasing. So non-increasing. Okay, so we go back to this function to where f of x is equal to x. We can simplify this to x, well, x times e to the 7x squared. But since this we were pushing it to the numerator, we can put the negative right there. We can use this to find the derivative, or we can use something a bit simpler, which is the low d high minus high d low, which is something that was taught back in Calculus 1. So f of x, this is the original function. So f prime of x is the first derivative of this function. So what the low d high, high d low formula states is that you take the derivative of the low, it's low, so whatever you have from your low, 7x squared, times the derivative of your top, minus, where it's low d high, minus high, yeah, so it's x, times the derivative of the bottom, which will be, let me see what I got over here. Yes, it'd be just negative, actually not going to be negative, just 14 x e 7x squared, parentheses. There we go, we can just do that. Okay, and now the denominator would be e 7x squared squared, because it's low times the derivative of the top minus the top times the derivative of the bottom, all over the low squared. That's why it's called low d high minus high d low. Okay, now this seems a bit tricky to see if it's non-increasing, non-decreasing. So what we can do is we can factor out an e 7x squared. 1 minus 14x squared. Because you see how we have a 14x right there and we have x right there, so that becomes x. Here, 7x squared. We can just leave that as that. We don't have to simplify that. So notice how if we put a 1 right here at the top, a 1 right there, it becomes 1 minus 14, which is equal to negative 13. Now the numerator will be negative and the denominator will be positive. That means the whole thing will be negative, will become negative. Now, something you have to see is that this e on the outside, it won't really affect anything because it'll just be positive. If it were to alternate between positive and negative, then it would be an issue. But since it's just going to be a positive number the whole time, a positive number times any negative number would just be negative. And then you know that your numerator would be negative and your bottom would be positive, then the whole thing will become negative. So all we're really focused on is what's inside the parentheses right here. And this is going to be negative forever, which means it's going to be non-increasing, meaning it's going to be decreasing. Therefore, the third requirement is checked off. Now we can use the integral test because all three requirements were met. So we use the integral from 1 to infinity x e to negative 7x squared dx. To use this, we're going to need u substitution. So, but first we have to make sure that since this is an improper integral because it has a infinity at one of the bounds, then we have to use limits to solve this. So this is equal to the limit as b approaches infinity, integral b, because b approaches infinity, we can replace infinity with b. From 1 to b, x e negative 7x squared dx. Okay, now we can use u substitution. So u, we can let it equal negative 7x squared. Now du will be equal to negative 14x dx. Now notice we don't have a 14x dx, but we do have a x dx. So what we can do is we can just divide both sides by negative 14. That would give us du over negative 14 is equal to x dx. And look, we have an x and we have a dx. So we can sub in back everything. But then before we do that, we have to change our bounds. Since we have this in terms of x at the beginning and we change it in terms of u, we got to change everything into terms of u now. So u is equal to your first bound, negative 7. You put your first bound in for your x. So it'd be 7b squared. And then your second bound would be negative 7, 1 squared, that's just equal to 7, negative 7. And then you rewrite your integral using your new bounds. So limit is b approaches infinity. Integral of your new bounds, you got to make sure it's 7b squared over negative 7. Now this changes into e to the u du. When you integrate this, this will be equal to, oh yeah, you can't forget the negative 1 over 14, because you see how we have a negative 14 over there? Yeah, this basically is the same thing as saying over negative